Hello, this is a short video presentation on factoring where the leading coefficient is not prime. If we look at this problem here, 6x squared minus 7x minus 3, and the instruction would be to factor. If I look at this, my choices for this first number in each of the binomials here, my choices are 2 and 3 or 6 and 1. My choice for the second number is obviously 3 and 1. So I have more choices here for the first one. It's not an automatic. So for instance, and this is really going to be a guess and check, I could try 6x and x, and I would like to add throughout this video, please use pencil. As I'm not always going to do it right the first time. I mean, I'm trying to show you how to figure this out, and if I did it the correct way at the beginning, you would really not be learning what you need to learn. So I could try 6x and 1, and then my only choices are 3 and 1. I can't use 3 here because then I would have a common factor. And if I put 3 here, when I did my double smiley face, I would have 18. Well, there's no way I'm going to get 7 when that's 18. So clearly, 6x and x is not going to work. So, let me just erase this. So I'm going to have to go with the 2 and the 3. 2x and 3x. And now I'm going to look at where to put my 3 and my 1. If I put my 3 here, I would have a common factor of 3. Can't go there. 3 has got to go here, and the 1 has got to go here. Because this is minus, one of them has to be negative, one of them has to be positive. So now I need to decide where the positive and negative goes. This is 2x, this is 9x. I want negative 7. So if this is 2 and this is 9, the bigger number needs to be negative. This is minus, this is plus. Minus 9x plus 2x is negative 7x for chunk. All right? A little more complicated. We have to think it through a little bit more. All right. The next one, 8x squared plus 16x plus 6. All right, I didn't say it in the last example, but we always need to look for the greatest common factor. I look at this and I have an 8, a 16, and a 6. Greatest common factor is 2. So we have 2 times 4x squared plus 16 plus 8x plus 3. Always look for that greatest common factor first. Number 1, you'll get the right answer, and number 2, factoring it without the greatest common factor is a lot more work. So now we have to factor this. My choices for 4 are 4 and 1 or 2 and 2. My choices for 3 are obviously 3 and 1. All right. If I start with the 2, I'd have 2x and 2x. And then doesn't matter where the 3 and the 1 go because 2 and 2 is the same. Gives me 6x and 2x. They're both going to be positive. 6x plus 2x is going to give me 8x. All right, that was pretty simple. 6x and 2x is 8x. So we're done. Again, the process is the same, it's just more complex, more things to consider. All right, last one, 12x cubed plus 69x squared plus 45x. Now these numbers are relatively big. Generally, when you have relatively big numbers, there's going to be a common factor lurking in there. So I look here, 12, 69, and 45. 3 is a common factor. X cubed, x squared, and x. We also have a common factor of x. So we pull that out, factor that out. Whoops, getting ahead of myself here. All right. Now 3 times what is 12? 4 and an x squared. 3 times what is 69? 23 and an x. Plus 3 times what is 45 is 15. Now my choices for 4 again are 4 and 1, 2 and 2. My choices for 15 are 5 and 3, and 15 and 1. So now we're going to try to factor this. Now I can start with 4 and 1, 4x and x. If I use 15 and 1, 15 times 4, and they're all going to be plus, is 60. There's no way I'm going to get 23. If I put 15 on the other side, I'm going to have 15 and 4 is 19. Again, not going to get to 23. So I know that's not going to work. What happened? Okay. So I'm going to erase the 15 and 1. I'm still going to try the 4 and 1. Now I'm going to go with 5 and 3. 5 and 3. I get 12 plus 5 is 17. That's no good. So I'm going to erase that. Bad choice. Put the 3 on the other side. 3 and 5. 20 and 3 gives me 23. So I got the right answer. If this didn't work, we would have erased the 4 and 1, and we would have tried 2 and 2, and done the whole process over again, with, in fact, the 15 and 1. So you pick one that looks better to start with, and if it doesn't work, you try the other one. Now, rarely will the number be so big that there's 3 pair. I usually, could happen once or twice, won't give you a number like 12 for a leading coefficient, or it could be 2 and 6, 3 and 4, 12 and 1. You know, we don't generally see them that complicated. All right, it's going to be a little more work, but the process will be exactly the same as what we've been doing. All right, I hope this helps, and have a great day.